Hello friends, in this video we are going to see the programming of customise LCD. To program this customise LCD we required a special microcontroller which has internal LCD driver. One of the best microcontroller is PIC16F1937 we can use for the programming of these customized LCDs. Now let us see the pins available in the microcontroller for the programming of this customized LCD. The pins are, first is what? Common pins. It has 4 common pins: COM0, COM1, COM2 and COM3, and it has 24 segment pins from segment 0 to segment 23. Okay, now to interface this LCD with this microcontroller, we have to connect common pins of LCD to the respective common pin of microcontroller. That is, common 0 of LCD is connected to the common 1 of COM0 to COM0, COM0 of LCD to the COM0 of controller, COM1 of LCD to the COM1 of controller, and so on. But the interfacing of segments, that is the symbol pins or segment pins, is flexible. You can choose any segment for any pin. Now in this case, see, I have used pin 5 at segment 3, pin 6 at segment 6, pin 7 at 8, pin 12 at 17, pin 14 at 19. This is randomly I have used. So this interfacing can be flexible. You can use any segment to any pin, but this is the mandatory. Okay, you have to connect COM0 to COM0 only, COM1 to COM1 only. Okay, so this is the interfacing diagram. Now let us understand the mapping of all the symbols on LCD with the pin combination of microcontroller. So for that I have made a Excel sheet. This first line indicate the microcontroller pins and second line indicate LCD pins. Now as discussed earlier, these 4 pins, that is the COM0, COM1, COM2, COM3, okay, these 4 connections are common. Okay, we have to connect these pins in this way only. It is compulsory, but this can be flexible. So in this case, pin 5 is connected to segment 3. Now what is the meaning of this? This RC is what? It is one symbol present on our LCD. This is the RC, which is this symbol is present this LCD. Now this RC is belong to pin number 5 of LCD. It is given in datasheet. Okay, it is given in datasheet. That is the RC is 5, DH is 6, 3I is 7. From now we connect this pin 5 to the segment 3. Therefore, for this symbol, understand this carefully. This is important. For this symbol RC, what is the combination segment 3 and COM0? Now these combinations we have to define in our program. Therefore it is important to understand that. Now similarly for this RH, what is the combination? Segment 6 and COM1. Now for this DP2, what is combination? Segment 9 and com 3. So these are the combinations which we have to define in our program. Now let us understand the program. I have written program already here. Now again see here, okay, this Excel sheet and this is the program. We have to define, this is the syntax, hash define. RC is what? Name of that symbol. You can use different name also. It is not necessary you use here RC. You can use here any name, but for simplicity we have used here name as per our data sheet. So for RC, now this is the syntax, define RC segment 3 com 0 underscore bit. Okay, this is the syntax. This is define, it's compulsory. This is compulsory. This middle name could be any one. Okay, so this is as a variable. This can be variable. Now define BATT. BATT is segment 3 com 1. Now suppose you are using segment 0 here. If one can use segment 0 here, so what is combination for? What is combination in that case? That is the segment 0 and com 0. We use segment 3, therefore our combination is segment 3. If the segment here is different, this combination is different, means this part is different. Okay. Similarly for 3a. Now 3a is what I have written here, S3a segment 8 com 0. 3a segment and com 0 S3a. Why I have written in S3a? Because name of variable could not start from number. Okay, so I have added here S, so S3a, S3f, S3 and S3d, 3a, 3f, 3e and 3d. So 3a is belong to segment 8 com 0, 3f is belong to segment 8 com 1, 3e is segment 8 com 2 and so on. So this is the definition, or we have to define combination for all the symbols. I hope you understand this. Okay. Now next is what? Initialization of LCD. Now if we see the data sheet of this microcontroller PIC 1937, it has different LCD registers and we have to assign the values to this LCD register. Now first LCD register is what? LCD con register. Now this is the 8-bit register. Okay. This is the LCD con register and this is what? 8-bit register from bit 0 to bit 7. We have to assign a value of this LCD con register. Therefore I have written here LCD con is equal to 0b. Now 0b indicate the number is a binary number and 0x indicate the number is hexadecimal number. So 0b, this is bit 7, bit 6, bit 5, bit 4, 3, 2, 1 and 0. So we assign the value one by one. So for bit 7, if bit 7 is 1, LCD driver module is enabled. Okay, so we have to enable our LCD value, therefore this value is 1. For 6, 1. For 5 and 4, by default this value of 0. We have to keep this value 0. Now this is what? Bit 3 and bit 2. For this, if we are using external oscillator, use 0 0. If we are using timer, use 0 1. And if we are use If you are using internal register, it could be 0 1, sorry, it could be 1 0 or 1 1. Now we are using internal register in our application, therefore this value is 1 1. You can write 1 0 also. So these two bits are these two bits are 1 1, and the last two bits, that is the bit 1 and bit 0. The value of these bits depends on how much COM port your LCD have. Now our LCD have 4 COM port, therefore the value is here 1 1. If you have 3 COM port, 1 0, for 2 COM port 0 1, and if there is only one common, 0 0. In our case this value is 1 1. Now the remaining all registers, the value of remaining all registers, we have to keep it default. So default value is given here. Okay, you can copy this value as it is. Next is, I have defined here a function. That function name is number display function, and I passed here two arguments. First argument is position and second argument is number. Okay, first argument is position and second argument is number. Now let us see what is this num function. Okay, now to show the number, these are about 3.5 digits of our microcontroller. Now to show number on these digits, I have written these functions. Okay, so now what is this position and what is this number? Now these three digits has different positions: position 1, position 2, position 3 and position 4. Okay, now I written function for only these three positions. Now if I want to set a particular number at this position, suppose I want to show 0 at this position, what I have to pass? This position is 1, therefore 1 and 0. Whatever I want to show, suppose I want to show 9, I write here 9. Okay, if I want to show 0, number 0. If I want to show 2, this number is 2. If I want to show 4, this number is 4. Position remain same. Now if I want to show at this position, then this position will be now 3, and whatever number I want to show, that will come here. Okay, now for that I used two switches. One switch is for position and another switch is for number. Now suppose for this position I want to show 1. What is written? Now see, this is the one switch for position and three switches to show number. One switch for this, second for this, and so one switch for position to show position and three switches for numbers. Okay, so if I want to show 1 here in this switch, come in this switch, suppose I want to show 1 here, I am repeating again and again. Okay, so position, at value of position will be 1, and suppose I want to show 1 here. If I write 1 here, what happen? If I write 1 here, it enter into this case 1, and if I write, it will check for case 1. If I write here 2, then it will skip this case and jump to this case. Okay, I hope you know about the how the case and how the switch block and cases are work. You maybe you know that. So to show here these two bits segments 1B and 1C should be high. See here. To show 1, B and C should be 1. So B and C is 1. To show 2, if I want to show 2, for 2, see here A, B, G, E and D. The red color segments A, B, G, E and D. A, B, C, D and G. Okay, A, B for 2, A, B, D, E and G. These are the 1. Similarly for 3, A, B, C, D and G. So for 3, A, B, C, D and G. All these are the 1. Similarly, remaining number or show for 0. For 0, A, B, C, D, E and F are 1. Okay. So it is shown in this case. Similarly for second position and similarly for third position. So this is the function for number display. Okay. Now let us come into the main function. Now in main function, we have to first initialize our LCD init function. Okay. Now see here, to show number, I have to call this function. What is the name of this function? Name of this function is number display. Number display. Now see here, this function has two arguments. First argument, it has two arguments. First argument is what? Position, and second argument is what? Number. Okay. Now if I want to show 0 here at position 1, so instead of position I will pass here 1, and at position 1 I want to show 0. Okay. So if I run this amount of code, so 0 is shown here. Okay. Now suppose I want to show 3 at position 3. 3 at position 3. So this first argument is 3, and at that position I want to show 3. Okay. If I run this code, play here, so see at position 3 there is a 3 3. Now I want to show number at all 3 positions. So what happened here? Number display, I have to call this function 3 times. I am going to copy this, Control V, copy and paste at position 1. Suppose now this is the position 1, this is position 2, and this is position 3. Now if I run this amount of code, see here, display shows all 3. Display shows all 3. If at position 1 I want to show 0, at position 2 I want to show 5, and at position 3 I want to show 8, suppose. And if I run this amount of code, see here, 850. Okay, this number is there. Okay, are you getting this? So this is what programming of customize LCD. I want to show a particular symbol. Suppose I want to show a battery symbol here. What I have to define here, the command will be BATT is equal to 1. I run it again. See that there is a number 850 and the battery symbol is displayed here. What if I want to show this diode symbol? Now diode symbol, if we see the diode symbol is, this is the S2. Diode symbol is what? S2. So just go into the program, write S2 is equal to 1. Okay, I can play this program. Okay, this diode symbol, so battery is highlighted, diode is highlighted, and this number is shown here. Okay, so that's for this video. In the next video we will see how to show a variable number here, or how to show a count. We are going to show counter here. Okay, thank you for watching this video. Please subscribe my channel and like the video.